Hello everyone. First of all, welcome to my channel, the Electronic IQ. In this video, we are going to study about the capacitor, and we also build a circuit using a capacitor and blink a circuit, blink a LED using a capacitor. Means how the capacitor store the energy you can see in that circuit. Okay. First of all, we have going to know about the what is the capacitor. The capacitor is an electronic component which is a basically passive component and which is used to store the electric charges. Okay, means like as a dam, a water dam, or a reservoir which has an amount of water in it. Okay, amount of water can store in it, just like an electric charges can store in that capacitor. I had one ceramic and one polar capacitor, but first of all we have going to know about what is the basically capacitor look like inside. I'll draw here. Okay, just like a capacitor symbol is like this. It's a ceramic capacitor. I think you see this. Okay, it's a ceramic. And for the polar capacitor we have draw like this. It's a positive, it's a negative. You look here, and the its unit is farad. We can calculate it as in the farad. Okay, first of all we are going to study about it, how it inside look like. It's a capacitor. You think here is the dielectric material, and these are plates. Okay, these are plates. This is also plate, which are conducting plates. These both are conducting plate. Okay, these both are conducting plates. Where there is a electric charges like this store here, and which are goes to another plate. Okay, a dielectric material means which material? A dielectric material means insulating material, which is insulate the current. Okay, means insulating material. Insulation, it's mostly used for insulation. And these two plates which are separated by this dielectric material, like an air, mica, or a paper. We can write here air, mica, or a paper. When like we can consider it as a polar capacitor, here plus, here minus. Okay, when the electric charges are come here, it goes to store here, and when it fully filled, means when it is fully charged, then it blocks the means when it is fully charged, if we stop the current in the circuit, it can discharge through, like if we connect a LED here, it can discharge, but it's not like that. We can draw a circuit like if we had a battery, like we can consider this is a circuit, here positive, here negative, where we had an here capacitor. Here we can use polar capacitor, and like parallelly we have to connect it parallelly with the LED. Okay, for protection we can provide a resistor to LED, and this is the complete circuit has been done. You see here. Okay, if I had a 9-volt battery, Okay, so uh, now what is the work, what is the main purpose of the capacitor? its its main purpose is to store the electric charges. Okay, and you know about the capacitance, na? What is the capacitance? Capacitance is the ability of the system to store the charges, or the voltage required to convert 1 volt of potential difference. We can also call it as a as it is capacitance. Okay, also we can calculate capacitance by using this formula: C is equal to Q upon V, where Q is charge stored in the capacitor. Mainly measured in the coulomb. And V is equal to the voltage across the capacitor, which is measured in the volt. Okay, now I had a capacitor, one polar capacitor. This is, you can see it, I can focus on it. Okay, you can see it. This is a 1000 microfarad capacitor, 25 volt 1005 microfarad capacitor, and it has two terminal. This is positive, this is negative. Okay, it look like just like this. And I had an one ceramic also. Okay, I will show you. Yeah, this is the ceramic. Here is the number on it for the calculation. Here is 56 number on it, means its value is 56 picofarad. Why its value is 56 picofarad? Because it has an here written here ACE, means what? Or we can also say that it follows the EIA rule, means electronics inductance alliance, electronics inductance alliance, EIA rules. Means where what is EIA? EIA means the default value of capacitor is in picofarad. If I had a value of 103 on it, if I had a value 103 on it, means this is the first digit, this is the second digit, and this is the multiplier. Just like an resistor, we can calculate it as a 10 into 10 raised to 3, means is equal to 10,000 picofarad, or we can write it as 10 into 10 raised to 3 picofarad, or can write it as 10 into 10 raised to minus 12 farad. Okay, or if we can in the we can write it as also 10 nanofarad. Okay, means it is look like a if 10,000 picofarad. then it is 10 nanofarad. 10 nanofarad, and we can write it as 0.000000001 farad, or in simply we can calculate it as an 0.01 microfarad. Okay, now we can simulate some circuit. Now simulate, no, not simulate, we can join some circuit and check how the capacitor is works. Okay, for that I had an breadboard, a 1000 microfarad capacitor. Okay, okay, a ceramic capacitor. We cannot use this ceramic capacitor in the circuit. It can store too much less storage. Okay, for it we can use this capacitor. Okay, and one resistor. This is a 100 ohm resistor, and one 9-volt battery. This is a 9-volt DC battery, and one LED. Okay, now also we need a jumper wire for it. This is a jumper, this is a connector. We require this connector and two jumpers wire, and one LED is required. Okay, wait, I will show you LED. Okay, I had this red LED. Okay, this is a positive terminal, this is negative terminal. Okay, now we have to join this circuit like as we draw on this paper. Okay, first of all we can do the capacitor. You know that na, this is the like this connection, this is a row like connection, these rows are connected, and these columns are connected up to here, and these columns are connected up to here last. Okay, this is a serially, this is a parallel connection. Okay, we have to this is a positive, we can fit it here, and one is here, negative here. Okay, now from it here, here is a capacitor positive terminal, we can connect a LED. Like we can connect it at it has a serially. Okay, okay, now we required one resistor, can connect it here, direct connect to the ground. For the ground connection we can connect it here. Okay, okay, now this ground is connected to here, okay, and this capacitor's ground is connected to, we can consider it as like here, can make it common ground here, and its ground connect, no required this, we can justly connect it as an here. Okay, not fully fitted. Okay, this fitted. Okay, you can see it, the negative terminal, a positive terminal. Okay, this is positive terminal of LED, negative terminal of LED, 100 ohm resistor, which ground is here, ground is common of capacitor and the and the all circuit is all the common, make it common. Okay, this is common, we can just connect a battery now. Okay, now uh, now here wait a minute, we required some space for the connection. Okay, here is positive connection na, here positive connection and here is negative. We can provide a negative first of all. Always must be remember no positive apply until all the grounds are become common. Okay, this ground is connected here, and now I only provide this here. You see that the LED is glow, but I remove it. Okay, I remove it. You see that how the LED likely slowly glows down. Okay, you can see it again. Wait a minute. This is ground and this is positive. You see that, and I remove it. Okay, how the capacitor is discharged. This capacitor discharges through this LED. Okay, again you see this its capacitor get fully charged and then LED glows. After when we remove the supply, the supply is from the circuit is gone, but the capacitor is charged. Then the charged from this capacitor are moved to this LED. Means this LED is discharge, means this capacitor is discharged through this LED. Okay, 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 ठीक है. So if you like this video, then subscribe my channel, comment and share to all of your friends who needs this video. First of all, I will thank you to all that visitors who can visit my channel and see the video. Okay, again thank you to all of you. Okay, bye bye, see you.